Good morning, everyone. It's a pleasure to have the opportunity today to address the audience on this very exciting conference that you all are attending. Um, I first want to thank, of course, Hungaro Control as well as the Hungarian Drone Coalition for arranging all this and all the technical hurdles we had to go through to set this up. And it's a great pleasure to be here with you today. Um, as is mentioned, the presentation today will be um, a presentation to highlight the different experiences as well as some lessons learned from our OneSky's global operations over the last 5 years of trying to really look forward to the implementation of beyond visual line of sight operations for all those who are hungry to get out there and apply beyond visual line of sight to many different industries and help the ecosystem move forward. A quick introduction, because many of you may not have heard of us, but we are located in the United States and Exton, Pennsylvania. We have offices in Singapore as well. Our evolution over the last five years, we come and have what we call spun out of, because we're not really a startup. We're evolving from a previous organization. That organization is Analytical Graphics Inc. And Analytical Graphics has been contributing to the aerospace and defense industry with analytics specifically and traffic management systems, most notably for the space traffic management system that our sister company, ComSpock, has been deploying globally. So AGI, we inherited over 7 million lines of aerospace grade code, 32 years of experience, as I mentioned, and we have worked with over 700 aero and defense companies globally. So AGI decided about 2 years ago to spin out OneSky as well as two of our sister companies into their own businesses. As you can see at the top, one is called ComSpock, which I just mentioned, and that's a space traffic management system. The other one is a geospatial tech company called Cesium, which many of you might have had dealings with over the years. And of course, OneSky. Our saying is we wish to harmonize the sky. We are looking to implement digital traffic management systems, not only for UTM, but for AAM, and also for the high altitude traffic management operations that are foreseen to come. So we're looking to facilitate traffic management systems across all altitudes of the airspace and assist with integration and interfacing, obviously, with the existing manned aviation traffic management systems. So we all know that low-level airspace is complex, and of course it gets much more complex as you move from visual line of sight or extended visual line of sight into beyond visual line of sight. There's so many things that have to be taken into consideration and managed, and decisions that have to be made. These are a number of them on the side of the slide there, but basically in dense urban environments as well as rural environments, the two big challenges that are being solved now, other than the traffic management system, are the communications links, of course, and detect and avoid. So when you think of detect and avoid, there's still a little bit of work to do to decide where are the decisions made. Are they going? When can they be made totally on the platform, and when would that be? That could be a challenge. But also, what are the decisions and the decision making and management capabilities of the UTM? How do they share that airborne as well as ground-based decision making? So that's an interesting topic that's going to evolve over the next few years. So, as I mentioned, part of this was to highlight some global experiences we have, because we always like to share the lessons learned with others in the ecosystem. Um, we've done an awful lot of work in the United States, of course. We have been very involved with NASA. We've been very involved with the FAA on all types of evolution of the UTM system, or the U-Space system, as it's known in Europe, towards beyond visual line operations. So, and at OneSky, we're agnostic as far as architecture. Our UTM framework really is end to end. In other words, it goes from a FIMS. It can be a USS architecture, or it can be directly to the operators contributing to either through a USS DSS kind of configuration, all the way directly to a FIMS. So we just basically think of this as moving the services around based upon the country's roles and responsibilities. In other words, we have the platform that's end to end. It can be configured any way the country wishes, and we just allocate the services based on the U-Space U1 to U4 across for the different roles. And we have demonstrated this, of course. The NASA TCL4 program was inter-USS, and that was following, was a little ahead of the ASTM standards on USS to USS communications. And also the NASA SIO, and we did the UPP2 programs there. The UPP2 were actually beyond visual line of sights at test ranges in the United States. So we proved out all the algorithms and the service components interacting with other UTM suppliers. So we're well on our way here to having a very robust UTM system with the almost up to U3 services at this point, and operationalized. Probably our biggest and largest operation for BVLOS was on our Civil Aviation Authority of Singapore project, and on that project we were actually doing a FIMS, we were doing a USS, a DSS. We were all part of the deliverables were constraint management systems, strategic deconfliction, and these were, sorry, I'm talking so much, I haven't done this. So on this program, as I was mentioning, this is in an urban environment, very dense urban environment, and we had to integrate the geospatial data and the aeronautical information into the UTM framework as well. We had to model UTM flight networks and simulate performance as well. So many drones, up to hundreds of drones flying at the same time in a network environment, being able to schedule, predict, and do conformance of the route monitoring. And we also demonstrated the inter-USS capabilities to enable BVLOS operations, as I mentioned before, strategic conflict detection and conformance monitoring. We were also asked to look at providing a service that would look at dynamic rerouting as well in that contract. So many lessons were learned there. And I would be saying it's probably the most advanced program, I think, that has gone on internationally as far as moving the needle. Oh, additionally, we also had to bring in dynamic weather constraints as well. You can see all these videos on our website if you wish to see the animated version of the performance. One very important thing, and as I mentioned to you earlier, the communications C2, as well as everybody's looking at how to get robust, redundant, or as high fidelity communication links as possible. And as you all well know, people are looking at mobile network operators. We have engaged with 3 different mobile network operators looking at the availability and the performance of coverage maps, trying to automate coverage maps to go to be deployed over greater areas, and having performance levels associated with them. We're also looking at what we call the micro UTM, being some of the services being hosted on the network itself, such as flight planning and dynamic flight routing and things like that. So all these things are evolving based on probably the ACGA standards that have come out somewhat, as well as we testing on all the performance, the links, and the handovers of the cellular signal at altitude. So these are very, very important to demonstrate the feasibility and the capability of providing a redundant and secure link from a mobile network operator as we go forward. There's some pretty amazing videos on our website of the trials we did with LTE performance with M1, which is a mobile network operator in Singapore. So I wanted to highlight that for you. Here again, as you can see, there's just a very simple picture of exactly, you know, how we recognize the pattern gains, how we look at the handover of, and this is a simulation of an urban air mobility vehicle, a taxi, an air taxi in Singapore, flying on a predetermined route, a corridor here, and we're looking at as it moves around the inner city cores. How is it performing? What's the performance of the network signal, the antenna propagation, etc. So this is valuable information to enable urban environment drone operations or urban air mobility operations. The signal coverage maps have to be analyzed and validated and performed before they're allowed to go into service level production. As well under the CAS program, we looked at dynamic corridors. Corridors being in the flight plan once it's authorized, of course, your route. What are the constraints on that route as you're flying it? The constraint managing of those constraints when you go out of volume and when you become contingent. How do you track it, and how does the operator and more specifically the airspace supervisor of the ANSP, how can they have visibility and when you are back in conformance or when you're out of conformance, and what are the decisions you have to take to make sure that you're conforming safely within the corridor of your flight route. Another program we did was really a very advanced, groundbreaking project, which many of you probably are very well aware of. It was the Swiss U-Space SUSI remote ID network ID deployment in Switzerland. We were part of about 8 to 10 companies that participated in this and went through basically the actual testing, the deployment, the testing, and the operational validation to that SkyGuide. We are hoping will be implementing network remote ID throughout Switzerland coming up. This was a very interesting project. There was a lot of partnerships. There's a lot of USPs involved. There were different facets of the ASTM standard that were validated, and as well as under a very secure and deployable framework. So at the end of the day, we have a certification. We're certified USP, able to provide net-rid services to all operators of drones in Switzerland. This, of course, is very important for the tracking of the drone as it's flying, and it's got obviously some security and safety aspects to it that provide great benefit to the authorities in Switzerland. So that was just a brief review of some of our operations globally and how we are always trying to evolve and adapt and make our services compliant with the standards as they are evolving. On our technology solutions that we provide for your BVLOS journey, OneSky is based on a common analytical services framework at the bottom that supports all our business operations. And it also feeds into our modeling and simulation analytics. We talk with OEMs, many of the major OEMs for urban air mobility to develop their ConOps to look at their how they're going to get approvals and waivers, even the design, what has to go into the design of their platform as they bring this to operationalization. Another segment of our business is the real-time operations and airspace integration, right? So UTM has started off basically with situational awareness, and that is ever increasing as more services become more robust and add greater management capabilities for operations in the airspace. But we do provide all these services: airspace visualization, BVLOS analysis, and of course compliance to all the regulations of the country that we're dealing with. And of course our suite of digital traffic management services. Not only UTM, but there's something called performance system, PSU, that's going to, people are thinking that that's the traffic management or operations management enterprise platform that urban air mobility operators will be using to help them guide their operations, very similar to an airline, if you think of it that way. And then there's a high altitude operations, the traffic management of that, which is is the kind of the newest traffic management capability that needs to be deployed. And to wrap up, I have a long background in air traffic management, as you can see, because I borrowed this, basically the arch diagram from ICAO and many other people that have tried to use that to show a step-by-step approach to UTM. And I usually present this to countries, ANSPs and CAAs globally, just so that their plans can be initialized and follow a transition path, let's put it that way. On the left-hand side, you see the services basically going up to U4, which we're not there yet, of course. And of course, the basic on the bottom right there, there's the absolutely essential registration system that I recommend that every country adopt first, because it's absolutely an enabler for many different services in UTM as you go forward. In addition, I might add that we recommend a phased approach because, different countries have different not traffic management, but they have different reasons for implementing UTM based on the demand of drone traffic in their country. So, you can phase in many of the UTM services and add them as you grow and as traffic demand grows in your country. Of course, you need the core platform, but then after you establish a registration, the core platform, basically you're good to start implementing the services that you need. I'm not quite sure where I am on time, but it always feels like I talk a lot. So I'm sure I'm going to end it here. And On a parting note, I'd like to just to thank Hungaro Control again and your drone coalition for providing us the opportunity to speak with you today. Thank you.